All right, now let's go the other way around. Suppose that someone gives us a normal, everyday two-column proof of a theorem. We want to see if we can extract the logic behind it and produce a flowchart proof. So let's see the flow of an argument given the proof. So here's the result that I want us to take a look at. So first of all, the first thing that we always want to do is just look at the result and see if it makes sense, if we like it, if we think it's even true. Forget about the fact that we know there's a proof out there about to come on the scene. So we're given that angle 1 is congruent to angle 3. So notice what do we have here? We have one line, and we have these two rays coming out. And I'm told that angle 1 is congruent to angle 3. So that's what we're given. And what we want to prove is that the measure of angle 2 equals the measure of angle 4. Well, somehow that's pretty believable to me because I just have one line here, and I see that these two are the same. And this, notice, is these two angles are supplementary. These two angles are supplementary. So the sum of the measures here is 180. The sum of the measures are here are 180. And if the measures of these guys are the same, and since the angles are congruent, we know their measures are the same, then the measures of these must be the same as well. So in my own head, I believe this is really a true statement. Let's now see the proof that we're given. So this is the usual two-column proof. And let's see if that sort of corresponds to what our own thinking was. So first, the first statement that's made is that angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. And why is that true? Oh, it's given. Right, that was given to us. So that's good. Okay, fine. Then the next remark is that angle 1 and angle 2 are supplementary angles, and angle 3 and angle 4 are supplementary angles. Let's see, angle 1 and angle 2 are supplementary. Yep, they lie on one line. Angle 3 and 4 are supplementary. They lie off this one line. So yeah, and that's what? Well, the linear pair theorem. So that's exactly right. They're lying on this one line. We have two angles, form a linear pair, so we know that they're supplementary. Okay, so far so good. So I'm liking this. Do you see how our intuition is sort of conforming with this person's proof? And what about the next steps? The next step is that angle 2 is congruent to angle 4. So angle 2 now is going to be congruent to angle 4. This is exactly what we were thinking about earlier. And why is this true? Well, this is the congruence of supplemental theorem. So that's good. And then what's the big last step? Well, since we know that these two angles are congruent, we know their measures must be equal, because that's the definition of what it means to be a congruent pair of angles. So in fact, we've actually deduced exactly what we were trying to prove, you can see. And this seems to be a nice proof. Now, let's find the logic behind it. So we find the logic behind it. How can we see this? So now let's focus on the proof itself and see if we can see the logic. Well, the first thing we do is notice that we have this given. So that given, in fact, I'm going to move this way over here too. So everything's going to be there now. You can see it all there, but I want to be able to write this down. So here's the given. And then what do we do with that given? Well, notice that we use the linear pair theorem to get that those two sets of angles are actually supplementary. So in fact, I use this fact together with the given to make what conclusion? Well, I conclude that angle 2 is congruent to angle 4. So putting these two results together, I use this, and I use this fact, and that produces this fact. You see how the argument's flowing in? And then once I have this, there's only one way to go. If the angles are congruent, I know their measures have to be equal. And so in some sense, here's a flow of the logic that we're seeing in that two-column proof. We take the given, we take this fact that we know using the linear pair theorem, and we pour them into making this conclusion by the congruent supplements theorem. And then taking that, just by the definition of what it means to be congruent, we know that the measure of the angles have to be the same. Oh, in fact, there's a typo here. Oh, typo, wait, typo. Wait, I love correcting typos on the fly because I want to show you that sometimes even people make mistakes. You see, that should be equals. The measures are equal. Ha! Look at me, on the fly, making the fix. So the point, though, is you can see the flow of the logic, which is hidden when you just look at a two-column proof. Anyway, when you look at proofs, sometimes it's great to look at it and see what's behind it, what's the logic, and putting it all together to prove the theorem.